Dr. Warden. Our next speaker will be Sam Ortega. Sam is the program manager for Centennial Challenges program, and he's going to tell you why do a CubeQuest challenge. So Sam?
So thanks, Jim. And actually, a lot of us are, and we're NASA, we want to do space exploration. That's our goal. But it's rather a difficult task to do because we have some technology hurdles that we're trying to overcome. And just like a lot of you are looking around trying to find out where I am, I have the exact same question. Where is the solution to my problem to solve this technology hurdle? I don't know who in this room has it for CubeSats, for communications and propulsion. And frankly, I really don't care who has it. And that's the whole glory, and that's the whole purpose behind the Centennial Challenges program, is that we want to solve these technology problems. We want to solve them in a very simple manner. And we do that very simply by setting the rules, by opening the challenge, and then by awarding a winner. And that's our exact goal here too, is that we set up the rules, we post those out, people start seeing them. We're going to open up this challenge for everybody to start engaging in. And frankly, I really don't care who it is. Because if you can achieve the goal, if you can provide the technology to help us do greater space exploration, we're all about it, and we're going to pay. So, in that vein, I've given away $100,000 to an artist in New York City who made a better astronaut glove for us. I've given away $850,000 to a video game programmer because he built a better vertical takeoff lunar lander. I've given away $1.4 million to an aerospace professor because he helped build an electric airplane that achieved 400 passenger miles per gallon. So for a lot of you that aren't into airplanes, they're going, so what, 400, who cares? A Cessna does 8 passenger miles per gallon. So there's a lot of great things that come from our challenges, and it comes from a lot of really diverse sources, a lot of really diverse locations. And that's the whole goal behind the Centennial Challenges program, is to solve technology problems. And we pay people to do that for us. We're going to have potentially a lot of solutions here, and that's exactly what we want. I could take this $5 million or more and give it to a single entity as a contract and hope that they deliver a product on time and under budget. Or I can take $5 million and hold it in the air and have multiple people coming forward and saying, I can solve that problem for you. Develop the technology, compete in the challenge, and we're able to look and use any of those ideas, as well as encourage them to go out and commercially sell them. So it's a win for us, it's a win for the competitor, it's a win all around for space exploration. So that's what Centennial Challenges is all about. Next chart. So this challenge in particular, that most of you hopefully are fully familiar with, we have this CubeQuest challenge. We've got 2 parts to it. There's the Lunar Derby and there's the Deep Space Derby. And within that aspects, we also have the ancillary part of the ground tournaments. So we're going to be offering, as Dr. Borton noted earlier, a possible launch for EM1. You have to do that, you have to compete within the ground tournaments. Actually, you only need to compete in ground tournament 4, if you read the rules. But there's money awarded all throughout the ground tournaments themselves. And then the culmination ends in down selecting to a segment of individuals and competitors and providing them the opportunity to fly in EM1. So if you don't fly in EM1, does that mean you can't compete? No, of course not. You can get a third-party launch at however you can. Any way you can get yourself into orbit or into cislunar space to be able to compete, that's great. If you meet the rules and you do the best, we'll pay you the money. So however you get there and however you prove it to us, that's where the money goes to. Thanks. So why the CubeQuest challenge? Form factor aspects, everybody's familiar with that, obviously because you're here. Current limitations, so most of these you're probably familiar with also, but in case you're not, we've pretty much only been in LEO. We've got fused cubes have gone out and beyond, not marinated. Communication subsystems, it's low bandwidth data rates, it's low transmit power, it's low gain, unique protocols, or amateur radio wavelengths. We have no in-space propulsion. Don't get mad yet. I know about solar sails. We've heard about this. But there's no significant high impulse propulsion systems yet that have been proven. That we're aware of. No deep space navigation. Future applications, obviously there's the astrophysics, the planetary, the helio, the Earth, the DOD, the near object exploration aspects. So all of those are the future potentials that come from the development of a system that can operate in a cislunar environment. Okay? So this is the potential that's out there commercially viable potential out there for competitors as they go off to enter this competition and develop their technology. And where do you take it? So you run the competition, and what if you don't succeed? What if you're not the winner? We always make sure that our competitions have a back-end business model. There's a terrestrial application or a space exploration application to it. So just because you don't win doesn't mean that it's the end. All you simply have the ability to go off and see if you can enter into. Hey Jason, is that you? Fantastic. We'll be wrapping up here in a little bit and we'll get you on mic, okay? So, and then we have the aspects of, so you can listen to. So the aspect of that is that don't feel compelled that, oh my God, I gotta win this challenge because if I don't win, everything's all lost. Well, no, we realize that that's not the only aspect of it. There's the ability to do a commercial application afterwards of the challenge. You know, and we're trying to do that through incentivizing small spacecraft, deep space operations, capabilities, development. You know, we want to help enhance the economic development within NASA, within government agencies, within academia, and within the space exploration industry itself. Challenge first, so this is the first time for an opportunity for a non-government entity to develop a spacecraft to go out into the cislunar space. Deep Space Com, as far as developing, incentivizing alternate solutions to this, doing something different than what we've always been doing as far as deep space communications. In-space propulsion, something beyond solar cells, although if you have a solar cell and you pull it off to win, that's great. Longevity in deep space, and then as well as the first ever in-space Centennial Challenge event we've had. So this is our first in-space challenge competition. Lastly, again, like I said, you guys are here because we're starting a new challenge. Excited about the number of people that we have and the interest we have in this. I encourage everybody to start talking, start interacting, and see if you're a single person that's only familiar with communications. Put your hand up and start getting familiar with the other people who are doing propulsion and avionics and packaging, and start partnering up and getting together with folks to see if you can't form teams. Registration is open, as you very well know. The kickoff summit is going now. And if you want more information, you can head over to nasa.gov/challenges. And then we will have on our page, there's the CubeQuest Challenge website. And then there'll be a link that goes to the detail page that's run through Ames Research Center, who is actually running this competition for us. And they'll have all the detailed information as well as the detailed contacts for the day-to-day interaction with the competition itself. And with that, Jim? 2 minutes. Questions, anybody? Concerns? Comments? Yeah.
Just to clarify, you mentioned on the first thing on your first chart, this is the first opportunity for entities, non-government entities to compete in these.
Right.
Not on the Google or X Prize.
So the Google or X Prize, you know, they are going to the moon. That's true. They do have to transmit data back, but again, nobody's done it yet. So until it happens, you know, we're all going to go in together. Although the other aspect of us for the deep space one is going to 28,000 miles, right? I mean, not 28, 2.8 million. So it's 10 times the distance of the moon. So 4 million kilometers, take your pick. That's well beyond. That's well into deep space. So you know, beyond the Earth. So. You know, take your pick. It hasn't happened yet. People are still vying to do that. And you know, we work closely with X Prize and actually consult them pretty much on a monthly basis, talking about prize and prize competitions. So yeah, we're both looking forward to seeing. We're both looking forward to developing and growing the cislunar commercialization aspect. Yes, ma'am.
Is that policy going to be written? Is it going to be written?
So your question is new policy going to be written? So, right. That's probably a good question. We have FCC. It's going to be here today or tomorrow. Tomorrow. You know, more than likely, yeah. Somebody's going to have to be starting to think about this. I don't think it's going to be as drastic as drones. I'm sorry, as UAVs. But it definitely, as more and more people start getting out there, the bandwidth's going to be more crowded.
there's going to be a challenge. People are going to have to start figuring out how are we going to do things differently as we start to commercialize the system area. So yeah, I don't think it'd be a problem for this challenge, but I do think it's going to be a problem commercially. Okay, folks. So hope you enjoy the day, and thank you for being here.